I am Optimus Prime.
Alright, our next concept has to deal with optimization. And whenever you're dealing with an optimization problem, you're asked to maximize or minimize an equation. And that equation that you're asked to maximize or minimize is called the primary equation. And then the secondary equation is what you use to get the primary equation to have only one independent variable. So, say you're given a problem like a rectangular page is to contain 24 square inches of print. The margins at the top and bottom of the page are to be 1.5 inches, and the margins on the left and right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Okay, so what they're asking is what should the dimensions of the page be, which you should note that that's area, so that the least amount of paper is used. That's asking you to minimize the area, is basically what it's asking you. So you should know that the area is the equation, your primary equation, because it's the quantity to be minimized or maximized, so primary equation. Okay. And it also gives you, the first part, it says a rectangular page contains 24 square inches of print. Now I drew a picture over here with the margins and with the width and the length to show you that when it says a rectangular page is to contain 24 square inches of print, that's like the only part that is going to have writing on it. So just this part of L right here that I labeled L, and this part of W, just that part is 24 square inches. And we can use that to substitute into our primary equation. So let's write the primary equation as A equals L, this is L, plus 3, because we're adding the margins here, because they're asking for the dimensions of the whole page, plus 3, and multiply that times W, right here, plus 2. And the secondary equation says that 24 equals just this L and this W, so L times W. Alright, now we're going to use our secondary equation to substitute into our primary equation. So you can get either L equals 24 over W, or W equals 24 over L. And I'm going to use this first equation. Actually, I'm going to use the W, just because I feel like it. You can use either one. But I'm going to use this equation to substitute back into our primary equation. So our new equation would read A equals L plus 3 times 24 over L plus 2. Alright, let me erase this to get this out the way. Alright, and then if you distribute in FOIL, you should get it to be A equals 30 plus 2L plus 72 over L. So that is the equation that we're going to try to minimize here. Okay, and to minimize it, what you want to do is, hold on, let me rewrite it at the top. So A equals 30 plus 2L plus 72 over L. First, you want to take the derivative of the equation. So A prime would equal, this constant becomes 0, plus 2, plus, and here we have a quotient rule, so f of x equals 72, f prime equals 0, g of x, which is the denominator, equals L, and then g prime of x equals 1. So if we do the quotient rule for this, you should get 0 times L, so that's 0, minus 72, because we're doing 1 times this, over the denominator squared, so over L squared. So plus negative 72 over L squared, and this simplifies to A prime equals 2 minus 72 over L squared. Alright, now You want to set this equal to 0. So we have 0 equals 2 minus 72 over L squared. And we're going to subtract 2. So we have negative 2 equals negative 72 over L squared. Negative 2L squared equals negative 72. And we get that L squared, if we divide negative 2 on both sides, we get that L squared equals 36. Now we take the square root of this and we get L equals plus or minus 6. Now your length can't be negative, so we can only assume, we have to assume that the length is just 6, not negative 6, because you can't have a negative length. Okay, so now that we have that the length equals positive 6, sorry. So we have L equals 6. We can plug that in to our original primary equation. Remember that we had A equals L plus 3 and times, W plus 2. Alright, and remember we also had a secondary equation that was 24 equals L times W. If we plug this number back into our secondary equation, we should get what W equals. So 24 equals 6W, and W equals 4. And then the primary equation should have our actual dimensions that they're asking for, since they're asking for the dimensions of the whole page. So we plug these numbers in, and we get A equals 4 plus 2 times 6 plus 3, which is also, whenever we simplify it out, is 6 times 9, which is 54 square inches. So our dimensions, because it's asked for dimensions, you should have two separate numbers. It would be 6 times 9. 6 by 9 inches. So here is your final answer.
I am Optimus Prime.